Hi everyone, and welcome to this webinar as part of Greener Infrastructure Week. Before we kick off, I'd just like to acknowledge the traditional owners of the land on which we are meeting and pay my respects to their elders past and present and the elders of other Aboriginal communities who may be here today. Aboriginal and First Nations people have been caring for country for over 60,000 years. So I'd just like to use this opportunity to share a bit about the local Wurundjeri seasons of the Wurundjeri people of the Kulin Nation, as that is the land that I'm dialing in from today. So Wurundjeri people celebrate 7 distinct seasons, November being the Borath Guru, or the grass flowering season, which if you are a fellow hay fever enjoyer, then I'm sure you've noticed the increased pollen in the sky due to the flowering grasses. And you may also have noticed a little bit more activity from some of our native fauna, including some microbats out catching insects at night, and also more sightings of common brown butterflies in gardens and grasses. And that is, of course, due to the beautiful grass flowering season. So our session today, welcome, is Concrete Steps to Carbon Reduction, in which we will be exploring how sustainability innovation is driving the reduction of the carbon impact of concrete. There will be an opportunity to ask questions at the end of the session today through the live Q&A chat function. However, if you've got any burning questions throughout, feel free to pop them in the chat and we will get to them at the end. It's now my pleasure to introduce your host for today, Rhys Owen Roberts, who is the Senior Manager Sustainable Infrastructure for the Big Builds Road Program as part of Major Road Projects Victoria. Over to you, Rhys.
Thanks, Lily. Okay, so welcome everyone to this session. We've got a great panel lined up for you today. I'm going to introduce our panel members. So we'll be kicking off with a presentation from a colleague, interstate colleague, Alberto Jimenez, who is the Senior Project Officer in charge of the Low Emissions Specification Program in New South Wales. He's been working with agencies in New South Wales to accelerate the adoption of low carbon concrete. We'll also hear from Miles Dacra from AECOM. Miles has over 40 years experience in construction and materials performance, and he's also been a very key player in the VIDA Low Carbon Concrete and Materials Working Group, which no doubt we'll touch on in a moment. We'll also hear from Raquel San Nicolas from the University of Melbourne. Raquel leads the Geopolymer and Minerals Processing Group, which is undertaking research into innovative concrete solutions. And finally, we also hear from Michael Staunton, who is the engineering manager at Suburban Connect, part of the Suburban Rail Loop. Michael has over 25 years experience in construction and is now driving the low emissions carbon concrete program for the Southern Tunnels as part of SRL. Now, before I do hand over to Alberto, I would like to just provide a bit of context in Victoria around the VIDA Transport Infrastructure Decarbonisation Strategy and why and the relation of this to concrete and the decarbonisation agenda. So we did a lot of work in preparing this strategy, which was released back in June this year. And as part of that, we looked at our upfront carbon footprint and tried to analyse and assess what the key parts of that were. And we found that 77% of our upfront carbon is in materials, with the remaining in energy, such as diesel burn and energy to power our sites. When we break down those materials, we know that concrete has around 42% of our upfront carbon as part of the materials component. So concrete is certainly a very important factor. We know that cement manufacturing around the world is accountable for around 8% of greenhouse gas emissions. So it's certainly a focus. And because of the amount of concrete that we use, it's certainly a big part of the carbon footprint of our works. Now, before we get into the panel discussion, I'm pleased to hand over to Alberto, who's going to give us a bit of context around some of the work that's being done in New South Wales around specifying low carbon concrete. So Alberto, over to you. Thanks.
Thank you, Rhys. And whilst I get my presentation sorted, just a second. I'd like to introduce myself. My name is Alberto Jimenez. I work with the New South Wales government within the low emission specific team. Most recently, our team was tasked with developing specifications or requirements for low carbon concrete, and for these requirements to be implemented, to support the implementation of these requirements in as many councils in New South Wales as possible. So today I would like to share some of the insights from that process. I think maybe if you are a council, you might be interested to understand what are some of the, whether it's possible, what are some of those insights from those processes. I've been working with 10 councils across New South Wales. Also, probably if you're part of the industry, it might be good for you to understand a bit more about council's move to better manage and reduce embodied carbon emissions, and what would it mean for you and the local supply chain. And more importantly, perhaps what is the type of information, or what are the type of conversations that I think I would like to see councils have with local supply chains. Now, in terms of the details of the programs, as I said, we were tasked with developing these requirements for low carbon concrete, and then to support the implementation with 10 councils across New South Wales. Currently working with 8 from various regions of New South Wales. So not just metro areas, but what would it take for a council in a regional area to these specifications and requirements. Now, in terms of the results, we developed the requirements and they are accessible via the MECLA website. Currently, we are working with 8 to 9 councils. We're expecting to work with 10 councils by the end of the program. And we have developed a variety of fact sheets and guidance, which are also available in the link in MECLA. So any technical, commercial questions, or maybe guidance on how to implement these requirements within your organization, this is all information that it's available to you. Also, a large part of this work was trying to understand what are the requirements, what would it take for the local supply chain to provide low carbon concrete. So all of the targets that we set out in the requirements were informed by current capabilities in New South Wales. Now, the low carbon concrete requirements themselves, they provide practical requirements for sustainability initiatives that reduce greenhouse gas emissions associated with concrete. So very quite in detail. So the specifications of the requirement sets out 2 reduction pathways. One, we nominate a minimum of 50% SEM replacement by way, SEM being supplementary cementitious materials replacement. And a similar target, if it is not by 50% SEM replacement, we also nominate an embodied carbon or a performance-based target of 40% embodied carbon reduction for all concrete being used on the project. So whilst the target is the same to reduce embodied carbon emissions from concrete, the way that target can be accomplished, we provided in a prescriptive way, that is nominating a hard SEM replacement target, or nominating an embodied carbon or a performance-based target. And this is acknowledging that whilst the industry, we're trying to move towards performance-based specifications because they do trigger innovation in industry, we also have to acknowledge that not all councils and organizations have that capability and are able to measure or calculate embodied carbon emissions. So whilst that capability is being developed, we have this prescriptive metric here, which nominates a 50% SEM replacement by weight. Now, in terms of how the specifications were developed, as I said, we consulted with industry. You would see that each of these targets has his kind of footnote here that said that this percentage can be adjusted on a project-by-project basis. And we really encourage councils and organizations to engage the local supply chains at least 6 months in advance to understand their current capabilities, understanding that it might be different in regional areas than it is in metro areas. So now, after developing the specifications, we also supported councils with the implementation. So that will usually looks is we provide these 2 training sessions. The first one is quite introductory, acknowledging that this is an emerging area for many councils. The councils do have net zero strategies, but they're only not all of them have are considering scope 3 emissions. So there's an emerging interest in this, and we need to acknowledge that we also have to train people in procurement teams, project teams, engineers and designers who perhaps are not sustainability professionals themselves. The sessions, part of this second session, like following that introduction or educational session, we do engage these councils and we do a bit of a mapping exercise. We bring procurement teams, project teams, sustainability teams, and engineers, and we try to understand the types of specifications they currently use. We have engaged with 10 councils so far, and we have discovered they use anything from like Australian standard specifications, NAT specs, Austroads, and Transport for New South Wales specifications even. And but some of these specifications, not all of them, nominate embodied carbon targets. So what we see happen is usually a council will just nominate the use of an Australian standard and add project-specific requirements. And what we are telling them is that in addition to those project-specific requirements, they should also consider nominating these embodied carbon targets when it comes to concrete. So now, in terms of the challenges to uptake of low carbon concrete, what we're hearing is that there's a lack of a holistic embodied carbon strategies by councils. So as I said, they have net zero strategies, but they are just starting to include scope 3 emissions, and they're trying to understand what does that mean. So like, how do you measure scope 3 emissions? How do you manage it, and how you reduce it? And as part of reducing embodied carbon emissions, there is designing out materials, and only then you land on material selection. And it is within this column of material selection that our work fits. The challenge there is that so far we've been working obviously with sustainability professionals, and it is in a voluntary phase at the moment. As councils gather more, increase their capability and confidence on specifying low carbon concrete. Lack of knowledge across the industry and previous experience causing resistance to change. So this is why we had to develop the fact sheets and the guidance. We have frequently asked questions as one of the resources, and kind of trying to address some of these, bust some of these myths that we have been encountering. But also working with the local supply chains to understand any contractor's experience and ensuring workability. So we understand that the use of low carbon concrete, whilst the long-term performance might be the same to regular concrete, there are some considerations that need to be taken in terms of the workability and when the concrete is being poured. The major concern that we have found is concerns about availability, especially for state level agencies. So how do you nominate these targets and they're still applicable to areas outside metro? So I think it all comes down to continue having these conversations, continue engaging these councils in regional areas, because then they have to also engage the local supply chain. And we have found instances where a regional council might be super keen to include these requirements, and then there is availability of that product in that area, but it might be that that council also has a requirement to maintain a diverse local supply chain. So how do we avoid instances where only one of the local suppliers can provide a low carbon concrete? Having said that, our understanding from engaging local supply chains is that they would be capable of updating their batching plans and provide low carbon concrete in regional areas, but they do need time, some 6 months in advance, to engage with council so they have enough time to prepare the necessary changes. Contractual barriers are usual. So how do you, okay, that's, you put that requirement. How do you, what is the reporting template? How does the tradie, when they buy the cement bag, sorry, the concrete bag at, I don't know, Bunnings or Meters or distributors, how do they report back the use of low carbon concrete? So is that a picture that they take of the bag and report it, upload it back into the reporting template? The challenge there is that then the information, the performance, the embodied carbon performance of that concrete needs to be included in the bag. And I think that's not always the case. So we have to continue working in that space to ensure that these products have either EPD or embodied carbon related data in the bags. And then the challenge that there can be an increase upfront cost. So using low carbon concrete might mean that you have a different LEH strength for the engineers out there. So if you're okay with having a slightly different LEH strength, then it should not come at an additional premium or cost. But we understand that if you want the same LEH strength, that low carbon concrete might need some additives and additional materials, and that's what can be costly. And we found what we've been told is some increase of 15 to 20% increase. So it is still up to the organization or the council to assess the instances in which they need low carbon concrete that performs at the same LEH strength as regular concrete. So now, ideal future state, lack of holistic embodied carbon strategies by councils. I think we are expecting development of these embodied carbon strategies to mature. It just needs a bit more of time. You have instances like Transport for New South Wales developing a measurement guidance. So we measure embodied carbon the same way in all the projects, but also at a national level. So you would expect all of those advancements to start trickling down into embodied carbon strategies by councils. Lack of knowledge across the industry. So we recommend continued engagement via industry groups like the Materials and Embodied Carbon Leaders Alliance or MECLA. In terms of concerns about availability, I think this is just a battle that we will have to continue having. So it's about how do we create demand, how do we continue supporting those councils, embed these specifications of target within their strategies. We need more accurate data, either EPDs or so on, and move towards performance-based specifications. I think we hope that will trigger innovation. We currently, it is understood that the use of fly ash to reduce the embodied carbon performance of concrete is a low-hanging fruit, and I think the move towards performance-based specifications would enable the use of other types of concrete that don't use fly ash, like calcined, clay, or geopolymers. We just need a bit more time. Experience of contractors on ensuring workability. Again, continue having those conversations in MECLA, continue engaging your local supply to understand whether there's any issue with workability. And then contractual barriers. We continue supporting the development of procurement and reporting tools, and continue putting this into MECLA websites. And also, we now want to explore working with procurement bodies. So, for example, the local government procurements. We know a lot of the councils, they just refer to existing contract panels by these type of organizations. So I think that's where we want to move towards next. And then in terms of potential increase of upfront costs, it's a nuanced answer. I can't give it to you right now. So I think it just depends on your engagement with your local supply chain and their local considerations, and trying to understand what time and effort is required for those local batching plants to be updated, whilst at the same time continue signaling upcoming demand. In terms of next steps, I'd like you to also stay tuned by the MECLA So we will be uploading a lot of our resources and events in that alliance. As I said, the low carbon concrete requirements can be found in MECLA. And if you have any questions, feel free to email at Alberto Jimenez, .Jimenez at environmentnewsouthwales.gov.au. Thank you very much.
Thank you, Alberto. All right, I'd just like to invite the rest of the panel to join me. Alberto, thanks for that. I mean, I think it's great to see this coming out of a central government department. So thanks for all the work you're doing on that. And as you mentioned, those guides and FAQs are all publicly available. So yeah, I'd encourage everyone to jump onto MECLA's website, and if you haven't gone through and looked at MECLA's website, then do so. They've got a number of other guidance documents which are really valuable and worth reading. I think some of those challenges we'll probably come to a little bit later. They're probably universal, not just restricted to New South Wales or local regional areas. I mean that you've given us a good overview of the context in New South Wales. Miles, I might just start with you if I can, because it'd be great if you could give us a bit of a background to perhaps the state of play in Victoria and some of the work that we've been doing through the Low Carbon Concrete Working Group.
Yes, thank you, Rhys, and thank you, Alberto. That was really good because, as Rhys said, you covered all the main issues that we're seeing, and it is a very complex, big problem because there's so many different moving parts. And I think that's the thing that we've realised all over the country, and it's collaboration is going to get us where we need to get across all the industry. I guess brief history, and again, it shows you how this thing moves. It's my recollection is that targets on cement reduction were first set for the Melbourne major rail project, the rail tunnel, and interestingly enough, I still have a memo put out by Louise Barrett, who's now with Ecologic, who was at the time the sustainability lead for Rail Project Victoria, and they set a target of 36% cement reduction back in 2017. So that was probably pretty groundbreaking. And for the three alliances that were going in, obviously the main tunnel, and I happen to have a role, one of my hats with ACON was on the Rail Infrastructure Alliance, which was also had that same target. So we immediately ran into all the problems that Alberto sort of just went through of how do you get that happening? How do you get your supply chain thinking differently? And it became very clear that, yes, you can solve a problem on a major project, but then how do you start to make it an industry change that we need to really move the dial completely on reducing carbon in concrete? And by chance, then I went from that job to a role with LXRP, and they had a materials innovation group, and that was one of the key questions that was going on. How do we get these lower carbon recycled materials onto major projects with all the risks, the structural, the costs, all the risks associated with it? And then it became clear we couldn't do it as a single program. We had to start getting people together and sharing information across projects. And at the time, you're quite right, Alberto. The figures you're quoting are what we're seeing now in Victoria. The sort of the 50% for in situ concrete should be the sort of baseline sort of reduction in cement content. But when we started back in 2017, 18, I would have said it was typically 30%, 25 to 30% would have been for cast in situ, and really 0% on precast because of the high early age strength. But to give you an idea now, we've just literally got an email this morning. We started using on the North East Link project a 75% cement reduction mix from Hanson, and the early phase strengths are coming in as well as a what I call a traditional GP concrete. So the industry is really adapting fast. The concrete technology is changing fast. The admixtures, the use of recycled material was all changing at the same time. So it's a really exciting time, but also complex. So as I say, the main thing we can do is share the information, and that's exactly what the low carbon concrete working group is. So we've got people from across the big build saying, we're doing this, who wants to take it on and run with it on the next one? So it's really exciting. And we've come a long way in a short time. Sometimes it's been really hard. I know Reese and Raquel have been out trialing a calcined clay just this morning. And, the logistics of just trying to get calcined clay that's not commercially available in the market into a concrete mix and get it on site was way more problematic than it should be. But we're getting there, and we're showing that it can be done. And this is really exciting. So, yeah, I can certainly really like what you're doing, Alberta. And we're trying to codify the same sort of approaches across all projects down here in Victoria. So I hope that gives you a bit of a taste for what we're doing.
Yeah, no, thanks for that. I think the 50% is definitely, I guess, where we would like to see those minimums going. I think Metro Tunnel, although it had a 30-odd% target, I think it's hit that 50% overall. So it's sort of, it shows you, I guess, particularly with those long duration projects, that things can shift. But yeah, thanks for mentioning the calcined clays, because yes, Raquel and I were both on site, or I'm actually, we're still at Mickleham Road where we're pouring. We actually did another pour today, which is really exciting. But Raquel, I think that's thanks for setting this up, Miles. But that's a really good segue, because I wanted to ask you about, your research. You're sort of at the forefront, I guess, of concrete technology, particularly looking at low carbon concrete solutions, and what's the next step beyond, I guess, those traditional SCMs that Alberto and Miles both mentioned, like fly ash and granulated blast furnace slag. They've been around for obviously quite a while, but we're having to explore what's next, aren't we? And can you tell us a bit then about some of your research and the calcined clays in particular? What's so special about that, and why are we sort of working on it?
Yes, of course. Thank you for having me in this panel. And I've been dedicated like the 15 years of my research on novel cement. And yes, I work on fly ash and slag. However, they are still byproduct. They are byproduct from other industry, and we are not sure about the supply chain. And we know they're going to reduce, or the demand's going to rise, etc. So we have been in the research, and I want to enhance the fact that it's very important to collaborate with researchers, because we are investigating those odd and more like. We were investigating 30 years ago that fly ash, or even 50 years ago, fly ash and slag, but now we are working on novel cement, novel source, more locally like calcined clay, that will allow us to move on and adapt the supply chain that we have, or the local material that we have here, and use it in new sustainable cement. And where it's important to collaborate with the researcher is usually we have done the research and we can bring the key information in order to assure to increase the confidence in the material, like having data on the durability, how it's going to behave long term, and etc., which is usually a big integration point when we are talking about new material. And that has been a lot of my research was focused on the best way to actually assess the properties and long term of a sustainable concrete. So yeah, I was working 15 years ago in France on calcined clay concrete, and we actually had it's accepted in concrete over there, and there are structural application and different. I think that and it's in use at the moment, and it's very important to get that ongoing as well in Australia, because the more traditional SCM that we have will diminish in the next 10 years. And we've got a great source of local material that can be not only mined, but also like being recycled. And there are a lot of actually dumped clay on the site that can be used as calcined clay. So in very simple term, calcined clay is just, we are taking clay, we are selecting like what we call the good clay, because not all clays are the same, and we calcine it from 650 to 800, and it activates it, and then it can behave as an SCM. So it can be using.
So Raquel,
yeah,
Raquel just saying calcining, so that's heating it up in a kiln rotating it round and getting that temperature up from, you know, ambient to somewhere around that 600 degrees, 650 degrees Celsius.
That's right. So you can use a rotary kiln, but there are also flash calciners that can be used. So it doesn't need to be a similar kiln than what we use for cement. There are some like more cyclonic vertical kind of furnace that you can use as well, and you calcine it between 650 to 850 depending of the clay and the time that they have in the furnace. So when it reaches this temperature, you make it active, and so we can use it as a cement replacement. And why it's very interesting is because we've got the local source available in the big cities, around the big cities like Melbourne and like Sydney. We've got HIPS in Tasmania as well, and Western Australia, etc. So we actually, when you have a look at the map of Australia, it's available. We've got the right clay, it's there. It just needs to be transformed, but we don't have the supply. We don't have the supply chain yet that is there. And that was the whole challenge of this project on Mickleham Road was really to have that was really a collaboration between the University of Melbourne, between Arup and MRPV, and also Hansen, and using the facilities at Renex and BMD to facilitate and offering the site to be able to scale this up and not only work on the concrete inside the lab and proving, which is very important to have the backup data, of course, but to be able to say, yeah, it's feasible. We can pour concrete. We can do it at large scale, and we've got the material, we've got the facilities. It's an option that we need to develop because the other one's going to slowly disappear. So yeah. So that's why it's very exciting what we've done this morning as well. It's trying to take
it is. I mean,
an alternative.
I mean, I'm not a concrete specialist, but I've become a bit of a concrete nerd, and I get really excited by it because you know, when you start seeing these Australian firsts, and it's the fact that a project, and it's the collaboration between government, research and industry that actually facilitates this and makes it happen, because without that, obviously things would move a lot slower. You know, so it is not only, you know, it's an Australian first, it's structural concrete. You know, I was talking to Raquel earlier on, she's installing monitoring equipment in this to have long-term data on the performance of these concretes, and which is really, really important. And I think you said, Raquel, that's never been done before for this kind of concrete. So,
no,
you know,
on this kind of concrete,
Australian first, world first, which is, you know, pretty cool. But, you know, I think it's important to point out that the projects, you know, are playing a really important part in this, and the huge investment that we have in infrastructure obviously is that kind of catalyst, and it's allowing us to progress some of these things. And I think, you know, Michael, you're obviously on one of the largest projects in Victoria at the moment, the suburban rail loop. Perhaps you could touch on, you know, what do you see the role of those major projects playing in you know, the sort of work that Raquel's talking about, and other emerging low carbon concrete technologies?
I think definitely being a facilitator and a bridge between research and scaled production. So with the projects, we've got the unique ability to trial pilots. For example, we're working with RMIT at the moment. I've got a high volume fly ash that's been in the lab for about 5 to 7 years. They've got a wealth of lab testing and data, but they've got no field trial of the ground slab. So we're looking at doing a 65% high volume fly ash ground slab for one of our equipment laydowns, and allowing the research team to come in, do destructive and non-destructive testing over a course of years for picking up and collecting data that can be then used to feed back into the numerical model, and then forecast and project what that long-term performance would be. Because we don't have, you know, we can't all put hand on heart and say, well, 100-year design life, what's the long-term performance? We haven't got 100 years. We've got to start putting these novel materials into practice. So yeah, that's what the big projects can do, and I think it's almost not that they can do it. I think they should do it. That's their role. I think there's a very strong. We have a number of incentives, commercial incentives, in play through what I consider a very well crafted procurement strategy by government for these incentivised target costs, where we have KPIs and KRAs for sustainability initiatives. But we need to look beyond just the project timeframe and maxing out that commercial incentive. We need to be looking about how can we have a viewpoint which survives past the project timeframe. And so that's why another initiative is, and we've been discussing with Raquel, is how does the suburban rail loop then pick up from where Mickleham Road leave off? So how do we continue the work that collaboration on calcined clay, how do we take that for the next 5 years? So it's almost like a project to project passing the baton in a very strategic way, so that we're contributing over a large amount of time the resources to see these initiatives go to scale, and not just be a flash in the pan in a research laboratory or a flash in the pan in a pilot on a project, but actually come to realization at scale in the supply chain.
Yeah, you're talking there about, I guess we don't have the time, but we've got to get these things in. But at the same time, we still need to make sure that we're achieving, that we achieve the outcome, right, which is a durable, strong concrete. That's why we use concrete. We've got to still make sure we do that. What are your thoughts around, and maybe Miles, you might touch on this, what are your thoughts on the durability aspect? I mean, that question always gets asked, doesn't it? Sort of, you use a low carbon concrete, but what if it fails? Like that's not a whole of life carbon outcome that we want.
No, but I make an observation. When Portland cement first was developed, it took us decades to actually understand what the durability aspects of it were. We were discovering that not until the 70s or 80s that we really nailed the idea that chlorides could migrate through concrete before that. So engineers have always dealt with materials and developed things and used them. And I'm very confident that we know enough about the mineralogy of the materials that we're talking about, because they are a combination of minerals, and quite often, as Raquel would tell you, they're actually all in the same bracket. It's just how they come together in a concrete form and therefore behave. So I think that's one thing we should dispel. The other thing was also to keep in mind that fly ash and slag weren't automatically found as the perfect answers. They were just researchers happened to come across them, and then a compelling commercial arguments have developed that here's a waste product, let's use it in concrete because it actually enhances some of the durability aspects, and we've been using it with enhanced durability aspects for a long time in marine environments, in particular in acidic. So let's not think that we know all the answers or should know all the answers before we take these things on. One of the things I would throw out there is that Australia, with its mining mineral waste, plethora of mining mineral waste around the country, processing waste, we should be we should be producing all our own cementing material out of waste. I believe. I think that's possible. I don't know what anyone else thinks, but I think that is possible. And it's just a mindset change, rather than just dialing up a concreter and saying, I need a 40 MPa concrete, is going, no, we should be looking, and as Michael says, and we should be trialing it on major projects under good controls with the right mindset. But there's nothing we shouldn't fear, I don't think, about getting this wrong, because I think we'll get it right more often than not. And we got it wrong in the past with GP concrete. One of the things this offers is that these concrete should be much lower heat. One of the Achilles heels of traditional OPC cement is it gets really hot in big pores, and that's always been a challenge to engineers to control that heat in the early phases, and the cracking and the alkali reactivities, the delayed ectronite formation that can control. So it's not what we're dealing with now is not a perfect material, and we could find something just as good, if not better, if we take this opportunity to look around. This carbon crisis is getting us to reevaluate what we're using, and it could be really exciting for Australia.
Yeah, it's interesting you're saying, mining. And I think I saw a social media post not that long ago about mine waste being used in a concrete application. But they're all sort of, I mean, a lot of these things are regional, aren't they? The supply of these materials, we're not manufacturing a lot of these things in the cities. They're coming, some of these materials are coming from regional areas. And I think, Alberto, you were talking about all those regional projects and the regional councils and some of the challenges there. I think it brings it back to, like, the supply chain is really important. We can't just focus on just the cities and the big urban areas. It's got to sort of cascade down as well, hasn't it?
Correct. So for us, those large infrastructure projects have been important because they have, in some instances, updating because of having to deliver low carbon concrete for those projects. The local producers have to update their local batching plans, and as a result, you've found councils that we wouldn't have expected them to have access to low carbon concrete, and in fact they did because they've been a previous large infrastructure project. But yes, you're right. How do we increase the market in terms of demand and the supply of low carbon concrete in those regional areas? And what you'll find right now is that some of these councils that we have engaged, then they go and call their local suppliers, and they're told, well, we can't really do this for this project for this council. You have to set that long-term demand. But what I think is that if all councils start asking for it gradually over time, and we start continue signaling upcoming demand, which will not happen until they have that kind of long-term embodied carbon strategies. In the meantime, all we have is that continuous engagement and asking and signaling upcoming demand. That's the best we can do, and there is power in aggregation. It's power of understanding what other councils are doing and what's being done in the area. And that aggregation piece, I think bodies like MECLA, which has councils working groups, is really important. How do you, can we virtually aggregate that demand via alliances like MECLA? Because otherwise we all kind of disperse and not asking for it in the same way, in the same tone at the same time.
Yeah, absolutely. I'm just going to jump into the chat because the Q&A, and then question from Joanna about, does calcined clay come from specific local industry? So I think, Raquel, you were talking about, the clay's readily available, all over the seaboard and over in Western Australia as well.
Yeah, there is. We've got clay everywhere in Australia, but there are some clay that are better than others, and we already have the data saying that around many of the major cities, we actually have the correct clay. I mean, the clay and it's really, really available in large quantities. When I say large quantities, it's like if you are completely substituting the demand of cement today, and you are substituting 30 to 50% of calcined clay in your cement for all the concrete that you are doing, we've got about 500 years of supply. So it is there, and then there is even more. So yeah, that's what I can.
But it in a way, it's an opportunity, though, isn't it, for local industries to develop, for job creation in regional areas. All these things kind of go hand in hand effectively when you start to utilize the resources that you've got, within your sort of your area.
Yeah, I was just going to add, sorry, Reece, I was just going to add the clay you're using at Mickleham, that's a byproduct of a Hanson quarry, isn't it? It's a waste, current waste out of their quarry, the clay, the overburden, and wash off their aggregates. So
that's right.
And we're seeing that there are other recyclers who've got similar clay products
I mean,
in their
this
streams?
washing process is done on nearly, I mean, a lot of quarries when we are washing our aggregate, but it can be also like overburden can be used as well. I mean, from quarries as well, but also excavation, as the project that we have with the North East Link, just trying to upcycle those excavation products from tunneling and from like big sites. And there we already have the material on site. So it is also cut the transport, you know, it is there.
Yeah, it's a really good point. Like these big tunneling jobs are generating huge amounts of material. And if it's good quality material that you can turn into, you know, effectively a concrete and use that back on your project, that's a really, you know, how good is that? That's such a great circular kind of outcome. And it, you know, all the emission savings that go with that in terms of all the, you know, reduced truck movements. But I did want to touch on that, you know, I think Alberto mentioned, you know, some increases around costs. Michael, I wanted to ask you Jeremy's question here about, you know, are there concerns raised around the higher SCM concrete and the additional time, but importantly, the cost that goes with that? How do you sort of navigate that, I guess, within the project? I mean, we're in this kind of interesting fiscal environment at the moment where, you know, budgets are really being tightened. There's a lot of scrutiny on how much we're spending and getting and driving that value. What are your thoughts on that?
That's to me, Reece. Yeah.
Yeah, sure.
So with Suburban Rail Loop, we've got a minimum 35%, which is now the base expectation. But yeah, we've got up to 50% being looked at. In terms of cost, I think the market is meeting us. So that's probably one of the major developments over the last 5 to 10 years is that, and Miles mentioned it before, 10 years ago, the market was really struggling. And contractors were very reluctant and almost scared of minimum requirements on SEMs. We have to step back and look at the progress over the last 10 years and see that contractors now quite readily signing up to a minimum 35%. They're looking at 50%. The market has got 2 or 3 reliable suppliers at scale who can provide, and so at a reasonable sort of competitive price. So not too concerned around price around SEMs. And when it comes to initiatives and supporting initiatives, there's for major projects, there's healthy incentives to invest in those pilot schemes and to look for and invest in the next batch of innovations that we'll be talking about in 10 years' time and looking back and say, well, we were scared about calcined clay, but now we're not, because we've got 3 calcinators in each state, and we've got scaled production. So yeah, I'm not too concerned around the cost side of things for the incremental advancement that we see in sort of 5 and 10 year blocks.
Yeah, great.
And the other question, sorry, if we don't do this work, the cost implications are going to get pretty horrid if once the supply of the existing SEMs starts to run down. The whole world's wanting fly ash and slag because it's the only mass market way of reducing carbon in concrete. So it's going to go up. So we've got to find these alternatives.
Yes.
Well, I mean, that is a really good point, because as we head towards net zero, you know, whether that's 2045 in Victoria or 2050 at the Australian economy level, you know, the cost of carbon abatement will have inevitably increase as you tick off those lower hanging fruit. And you know, something I always think about is if you don't invest in these things early on, when you have the opportunity to, then you're effectively kicking that can down the road, and ultimately you've got to be paying more in the long run. So I think, you know, where you can facilitate these things through projects. And the value for money question is still really important. I hope the message doesn't come across that you're sort of kind of throwing caution to the wind and you go and do any low carbon concrete regardless of the cost, because that's not a sustainable solution either. It's got to be, you've got to be able to demonstrate that value, but at the same time you've got to look at how much and how you can invest in it. But the calcined
on Melbourne Airport Rail Link before we stop. Our project managers negotiated the same price for a 70% SEM mix for piling as they would have paid for a normal. So if it's all
supply and demand.
Yeah, it's exactly right. And Michael, I think is right. The industry's there, and these prices don't need to be much at all, if anything. So hopefully calcined clay might actually be cheaper. So we'll see what happens.
Well, yeah, we will see. I mean, again, it's not necessarily the silver bullet, is it? But it is one thing that we have to explore these different options. But Patrick's asked a question here about, which is a really good point, a really good question, because we didn't touch on it in too much detail. But noting that Raquel, you have to put the clay through a furnace, whether that's a rotary kiln or a flash calciner, and there's obviously different energy requirements for each of those. But this isn't like an energy neutral thing, is it? There are still some emissions associated with, but how does it compare to traditional cement, and what's the difference between that emissions footprint?
So it reduces, at least, even though yes, we are using energy in order to calcine, but it's it's less than half than what you would use for a cement kiln. I mean, in matter of temperature, that's what I'm talking about. The embodied carbon is estimated between like 50% less than a traditional cement, but it can but if the supply chain is in place, it can even go up to 70% less of the compared to a traditional cement. So which means that calcined clay will be around the same kind of emission than slag, which is and it's not reaching as low as fly ash, but it is in the same range than slag, and it can be even lower depending of where the slag is from and etc. of the other parameter. Yeah. So that's where calcined clay sits.
Yeah, and I think one of the key things for people to keep in mind is that the manufacturing of cement, which is actually the really carbon intensive part of the concrete, the cement is, you're taking limestone and putting that into a kiln, and it's the decomposition of the limestone into lime and clinker that releases huge volumes of carbon dioxide. So you're getting that release from the chemical process, and then the energy that goes into the kiln as well, which is obviously higher. I think, what is it, 1,200 degrees or something?
That's right.
Yeah, to make cement. So with calcined clays, we've got a material that's not decomposing and releasing through that chemical breakdown. We're not having the release of carbon dioxide there, and then we're also using less energy to actually make it in the first place. So it's sort of tackling it from two ends. And I guess, with more efficient flash calciners, can they be electrified? Is this sort of, is there a pathway to a carbon sort of renewable?
It is possible to fully electrify flash calciner as rotary calciners. The only issue that we would have today is the infrastructure that will allow to this energy to be attributed to a plant like that. But that's the same with like when we are making steel and etc. It absorbs a lot of energy, even if it's clean energy. So, but it is possible. Yeah.
Yeah, I mean, yes, for all those heavy industries, that are reliant now on natural gas, that there is a big challenge ahead of us. But I guess as that whole grid decarbonizes over time, that energy will become increasingly available. Just looking at the questions, like Stephen Howe has asked a question here about the UK's HS2 projects. Raquel, you might be close to this. I know Arup, I think, have been involved in that overseas in London. They were looking at getting funding for a calciner to do something similar to what North East Link are doing, which is taking excavated material and calcining that on site. Have you heard any updates on that?
So it has been put on pause earlier this year, but the intent was exactly right. Arup was heavily involved in this study, and so they extracted the London clay and they tested it and calcined it as well. And the idea was also to get on the on the project a mobile calciner that would be that will allow to transform the clay along the excavation and the tunnel, which is a very like a great way actually to overcome the supply chain and just work on site when you are excavating and transforming directly the material and get a cement on site. So it has been on pause, and I hope it will move to the next step very soon in order to be taken on again and be used on this project, because the London clay had great properties as well.
Yeah, good. Well, we've got a few more minutes for questions. If there are any, please pop them in the chat. But I guess one of the things we haven't really delved into, and maybe I'm opening the can of worms here, and this, Miles might have a quick answer for it, but standards, specifications, returned asset owners, their requirements. Are we limited by that? I mean, we've just poured calcined clay today on a DTP asset, so clearly there are ways to do this. What do you
think? I think it's everyone, I think I remember at last year's, I think it was the Ecologics conference, I think even the minister at the time, the premier, or it might have been the year before, she said we do have to take risks to get to zero carbon. But within the engineering field, this isn't a huge risk, but it needs to be done properly. But as you said, calcined clay isn't currently in the specification, but DDP, to their credit, they're looking at things on the, not on the fly. They're looking at them seriously, but they're approving things under the watchful eye of the low carbon concrete working group. And we've got a 75% mix approved by their approver, Entro, and that doesn't comply with the letter of the DDP specification as it currently stands. So, like everything in life, if everyone's involved in the conversation and kept up to date, I think we can move past the barriers with everyone involved and everyone being made aware of what we're doing and doing it in this way. But one of the things I think we do need to do is have, in the past, standards have been written by people in their spare time, by, in the industry who give their time. I think we've got to, during this climate crisis, we've got to potentially look at, should we be paying people full time to really get on top of the data that's coming out and get the standards and specifications updated quicker and actually have them as live documents, because we're going to be moving at a speed that they can't possibly keep up with otherwise. So I think it's that thing of having proper governance, technical governance over it, and keeping everyone informed. If everyone goes behind their shields and tries to develop things in isolation for commercial advantage, we're not going to move as quickly as we need to. So the other shout out is, everyone, please share your data. We know people are doing research in calcined clay right around the country, in private. We've got to share it, because otherwise, the key stuff we've got to share. Otherwise, the body of knowledge won't advance quicker enough, as quickly as it needs to. So
well, we'll be looking to share everything we can on the work that we're doing. I know Raquel will probably be writing a number of papers, and we'll be getting that word out there. So don't worry about that. From our end, anyway.
Can I add something on that, Rhys? It's just like it's not only calcined clay. It can be like any other SEM as well. And I've heard sometimes people saying like, we've done our test in the industry. We know that it's behaving, but it hasn't been published in any journal, or it hasn't been advertised, and etc. But they said that they know that the durability is okay and everything is okay. However, we cannot build up on a word to mouth maybe and without seeing anything. So I really resonate with what Mike said. And yes, sharing, publishing, and showing that actually those SEM, we know that they're going to be better. And why I investigate more time on the calcined clay at the moment is because we already have a lot of data. It has this advantage that it has been investigated overseas, even if it's not exactly the same clay, but though we know that at long term it behaves well, and we already do structural application with it. And that's why, it has this edge compared to lithium slag or other kind of material or SEM that would be great to have also on the market, but we don't have this backup data. I just wanted to.
Yeah. All right, we're nearly out of time. There's two questions we haven't got to. One around the recyclability of low carbon concrete. I think I can answer that and say, you know, when we're talking about high SCMs, yeah, absolutely, it's recyclable. You wouldn't know any different there. Obviously, if you start introducing other things into the concrete to reduce the carbon, then that's a different question in terms of, you know, sort of say plastics and other things. But even that, you know, we know that recyclers are very good at that. And Steve Morris's question around asphalt. So our low carbon concrete and materials group is looking at a whole range of different things. Low carbon asphalt certainly is one of those areas. But that is all the time we've got for this session. I hope everyone's enjoyed the conversation, and hopefully you've learned a little bit. But Lily, I'll hand that over to you just to close out.
Wonderful. Thank you so much. Thank you so much again, Reese, and to all of our wonderful panelists for leading the session today. And of course, big thank you to everyone for dialing in and joining us. We have a lot more interesting sessions this week, including our Build Waste In, Plan Waste Out session, which starts this afternoon at 2 p.m. And also our contract incentives to drive sustainable outcomes at 10 a.m. tomorrow. If either of those sound interesting or any other of the sessions this week sound good, scan that QR code and register. We hope to see you there. Thanks so much, everyone.
Thanks, Lily. Thanks, everyone.